All right, hello everybody. I'm about to give you a quick review of what we did today in class. So what we did, well, first we talked about average cost curves. And well, first of all, formulas. We need formulas to get average costs. So you get AFC as FC over Q, right? Basically you divide everything by Q and you get your averages. AVC is VC over Q, and ATC is TC over Q. And also, you might recall this formula we saw earlier, TC equals FC plus VC. So if you divide everything by Q, you will get the following. ATC equals AFC plus AVC, which can be rearranged, so you can express AFC as ATC minus AVC. So we're going to use this formula today. So we need to know that, right? Also, you actually can go back very easily. So if you know your AFC, then you can get your FC as AFC times Q. You can get VC as AVC times Q. And you can get TC as ATC times Q. Okay, so and this formula and actually this formula should give you exactly the same result as this one. So whatever you have available, use either one, and so if you use them properly, you'll get the right answer. All right, next thing is to look at those curves. So let's see how they look like. And basically, we're going to look at this guy, AVC, this guy, and also we will plot MC. Remember, marginal cost is change in TC over change in Q, or basically it's the slope of total cost curve, which also can be calculated as change in variable cost, right, over change in Q. So we're going to see three curves there, and I will tell you how we're going to deal with AFC. So they are all U-shaped curves. So let's draw ATC first. This is ATC. Then I would draw MC. You see MC is crossing ATC at its minimum. So maybe to make it a little bit more accurate, I think that's good enough. All right, so MC crosses ATC at its minimum. Next thing we're going to draw is AVC. AVC is another U-shaped curve, and it kind of merging with or trying to merge with ATC. Why it's trying to merge with it? Well, we'll get to it in a minute, but let's just notice that again. Here you see MC intersects this curve also at its minimum. So this is minimum AVC. Right? Right, I'll get rid of it because I need this space. So why are these curves emerging? And in fact, where could we find AFC if we are not drawing it as a separate curve? Well, it's very actually straightforward. Remember this formula? AFC is just ATC minus AVC. So at any Q, you can figure out your AFC as the difference or distance between these two curves. But you have to be careful making sure that you set your Q, because depending on where your Q is, you will get the distance between these two curves. So at this Q, for example, let's say Q1, this is your AFC. All right, again, it's just ATC minus AVC. That's how you get it. And if you are wondering how AFC curve looks like on its own, if we drew it on its own, then it would look something like this. This is AFC, which is FC divided by Q. And remember, FC never changes by definition with Q. So as this thing stays the same and quantity is getting larger, while the whole ratio is getting smaller, that's why this curve is downward sloping. And as Q gets very, very large, well, AFC gets very, very small. And that's why actually these two curves trying to merge as Q is getting larger. All right, so let's actually see how we can find some variables on this diagram above. So let's actually pick a smaller Q. So this is, let's say this is Q2. So at this Q, you draw a straight vertical line and measure all your variables of interest against this vertical line. So your ATC is this guy, right? Because this is where you hit your ATC curve. This is where you hit your AVC curve at this Q. You see, everything is happening here. So you get your AVC. Well, to be exact, you get AVC at Q2. And you get your AVC at Q, well, sorry, not AVC, but ATC. Okay, so another way to see it is by showing ATC as this vertical distance and showing AVC as this vertical distance. And also you can show this distance and it will tell you what your AFC is, right? So you see it's actually different because AFC is getting smaller as you're increasing your output. So because Q2 is actually not as large as Q1, AFC here is fairly large. So this is AFC at Q2. Another thing you can actually see on these diagrams is totals. So we already picked this for AFC. So AFC times Q, as we just saw here, right? AFC, where is it? Yeah. AFC times Q will tell you what your FC is. So this box is telling you what FC is. This large yellow box tells you what your TC is, and this pink box is telling you what your VC is. So this is your VC, this is your FC, and the whole thing, the yellow thing, is your total cost. All right, so another interesting thing is something about fixed cost. Remember, fixed cost never changes. So as you changing your quantity, you will see that those boxes changing their shape, and most of them actually also will be also changing their size, but not the FC box, because FC box will always stay the same in terms of its size by definition, right? Because fixed cost doesn't change. So it might get longer, right, and thinner, but technically, I'm not sure if it actually looks the way, but if you draw these curves properly, its area is supposed to stay the same. And again, that's because FC is always staying the same. So you can figure out your fixed cost, total fixed cost, just picking any Q and just figuring out the area of this box. Okay, so that should be it for our cost curves. Took me 9 minutes, not terribly quick, but well, that's we have a lot to cover here. So I will try to increase my speed as we're talking about profit maximization. So what about that profit maximization story? So how to maximize profit if you are a price taker. Okay, So we talked about price takers, right? Price takers are companies that cannot influence the market price. And that's basically always the case when you are too small and you're producing something that is pretty much identical to what everyone is selling. If this is the case, then you just take the market price and you just deal with it, right? And so simply put, what's going on in this case is that the market price is determined by supply and demand, right? We saw it earlier. And there are a lot of companies behind this supply curve, right? And a lot of consumers behind this demand curve. So each one is a price tag. Just like when you walk into into a store, you cannot really tell seller, to sell him this stuff cheaper price. I know it's not common to bargain like that. So same idea with sellers here. So that's like the market story. So the price only adjusts when either supply or demand move as a whole. But as long as supply and demand stay the same, each company just taking the price. So this is the firm situation. And the thing is, no matter how much or little the company will produce on its own, the price will not be affected. Again, the idea is that the equilibrium quantity, which includes all quantities produced by all these numerous companies, will not notice these adjustments that one individual company is making. So we pretty much can ignore the fact that adjustments in quantities, the way they affect the price. I mean, of course, theoretically there is some effect, but we can pretty much ignore it, right? So that's the way things work when the company is a price taker. And if you know someone's price, I mean the price you're selling your stuff at, you can figure out your total revenue. It's P times Q. So whatever Q you pick, your total revenue will be just your price times quantity. So that will be your area, your profit. Sorry, total revenue, of course. I'm already thinking about profit. So profit. What about profit? Well, profit is very important because that's what companies are after, right? They don't just want revenue. They want total revenue balanced against total cost. So it's not like you're maximizing total revenue or minimizing your total cost. You just need to find a balance. In other words, you want to make this difference as large as possible. So the goal is to maximize this difference, which is your profit. All right, and an important thing is that you can only do it by adjusting your quantity. So our goal is to figure out what should be the quantity to achieve the maximum profit, because everything is given. Cost curves are given, price is given, that's it. The only thing you can play with is your quantity, which, by the way, you can adjust by playing with your labor, right? Because labor is your variable factor of production. Okay, so now let's go to that pre-made slide and figure out how things work out here. So to figure out what Q you should get, you can look at two graphs, and the one above might be a little bit more intuitive, but eventually we need to understand how this lower diagram works. So let's start with the one at the top. So on the top we have what? We have two curves. We basically have everything we need, right? Because profit, again, is what? Is total revenue minus total cost. So we see total cost, we see total revenue. So you can just pretty much figure out where total revenue curve is as far as possible away from total cost, assuming that, of course, it's above total cost. So, and which means you have to look for your maximum profit somewhere here, right? Because that's the only area where total revenue is above total cost. And well, I can tell you right away that it looks like this is where the distance is the largest. So this is total revenue, this is total cost, and that's the biggest difference you can get. So that's the largest profit. All right, well, so you can just eyeball it and figure it out. But we want to be more, I guess, particular about it. We want to be more rigorous about what's going on here. So what we can notice here is that actually the profit is the largest is when basically at the point where the tangent line to total cost exactly matches the slope of our total revenue curve. In other words, that's basically when marginal revenue equals marginal cost, because marginal cost is basically the slope of our total cost curve, or the slope of this tangent line, right? And marginal revenue is just the slope of total revenue curve, which is price. Okay, so that's the condition that tells you that the quantity is giving us the largest possible profit. So if you are at the point where MR meets MC, it means that you are getting the largest possible profit. Okay, so this Q asterisk is the one we want, because that gives us the largest profit. So profit is maximized. All right, but we have to be careful, because this rule is pretty universal, but it only works if Q is not 0, because there will be some instances which we're going to look at later on, when it's actually better to set your Q to 0, and so in this case this rule will not apply. But for now it's just going to be fine. Simply put, if company could make positive economic profit, then that should be the rule to stick to. All right, so we figured out the upper diagram. Now let's go down and see what's going on with the lower diagram. In the lower diagram, we have marginal cost curve. We know how to get it right from our previous discussion. We have ATC curve, and we also have our price. We assume that we know it, of course. So let's see what's going on here. The fact that the slope of this curve matches the slope of this line pretty much shows here as the intersection of price curve, because it's the same as marginal revenue, and marginal cost curve. So when they meet, it actually means that, yeah, the slopes of these two curves on this diagram match. So if you don't have this above diagram on the top and only have like the lower diagram, that's how you figure out your profit maximizing level of output. All right, so a few more things. Well, we figure out the profit maximizing level of output, but where can we actually see the profit at the lower diagram? So how large is the profit? I mean, here we could see just this distance, right? So if you actually read these numbers for total revenue, total cost, you can just get your profit. But here we don't have total revenue and total cost, but we in fact have everything we need to figure it out. So on the lower diagram, if you just follow the basic formula, you still can get everything you want, because total revenue is nothing but price times Q. Total cost is ATC times Q, right? And we have all those things at the lower diagram. So you can rearrange it as P minus ATC times Q. All right, and we have price here, P, and we have we can look up ATC at this quantity, and of course we have Q, so we're all set. Again, just remember that this formula works if Q is not 0. Just warning for the future reference. Okay, so the final thing is to figure out where is that profit. Okay, so let's look for it. First we need to find this P minus ATC. Well, we know that, again, actually in fact we should start with Q. So we know we are supposed to be here, so everything is going on here. So at this Q, price of course, well, it never changes, so this is our price. MC doesn't matter, we just used it to find Q asterisk. And then we can look up ATC. So P minus ATC is this part, and Q is another part. So graphically, you can actually see your profit as this box. Let me pick a different color, something bright. So this is our profit. This is our profit, but probably we need few more variables to be clear what's going on here. So let's make a few more observations. Where is total revenue on this diagram? This is, oh, sorry, I meant this. So this is total revenue. So where do we find it? This is price times Q. So that gives us this area for our total revenue. Where is our total cost? Well, it's ATC, which is this, right? We just got it from here, times Q. So that's, this area is telling us what total cost is. And total revenue minus total cost, total revenue minus total cost, so in other words, this area minus this area leave us with this area for profit. So here we go. So let's just put few more marks here. So the yellow tells us what total revenue is, and the green tells us what total cost is, and I already marked profit here. All right, so that concludes our review, but let me actually, just one more thing. You guys might recall it from our discussion in class. Please, please, please stay away from this point. A lot of people fall for picking profit maximizing quantity against this point. And basically this is where ATC is at its minimum. We don't want to set our output there because it will not maximize our profit. We want total profit to be maximized, not per unit profit maximized. Because if you set your output here against this point, you will have the largest possible distance between price and ATC. That's true, but it's not what you want, because you will make this area as tall as possible, but in fact you will make it much shorter than it could be. So you want this area for your profit, not this area for your profit. So this area will be a little bit again taller, but because it's shorter, you actually will lose more money by picking this quantity compared to being in this quantity. So in your assignment, actually it's a good exercise to actually calculate profit at this quantity and see what you get, and compare it to profit you get at this level of output. And you must see that you're better off when setting Q here rather than here. All right, I just made it in 25 minutes. Thank you for your attention. I hope it was helpful. I'm stopping here.